Light is not something which reveals. Light is itself a revelation. Pranam. I'm Aishwarya S. Rathore of Salvan Public School, Mayur Vihar, Delhi. Today, I'll be performing experiment to show reflection and refraction of light. So to begin with the first one, the reflection, I have a laser torch, a plane mirror, and a sheet of paper which will be my plane. This glass prism doesn't have any role in my experiment. It's just for the support of my plane mirror to make it stand vertically. Okay. Um, Now if I switch on my laser torch, a narrow beam of light is emitted and it's striking this plane mirror and then getting reflected. To get a better view of the path of light, I would like to switch off my room's light. See, I'll adjust my laser torch in a way to get a clear path. Mm, yeah, now we can see. See, this ray is the incident ray because it's the ray which is incident on the mirror. And the other one is the reflected ray, the ray which is reflected from the mirror. And I've also drawn a normal perpendicular to the mirror. This is how reflection takes place. And from here we also get our laws of reflection. The incident ray, the reflected ray, and the normal all lie on the same plane. For this case, my plane is my sheet of paper, this one. We can switch on the light. Yes. So we also have a second law, and I'll be explaining it through a diagram. The angle between the incident ray and the normal is the angle of incidence. Angle between reflected ray and normal is the angle of reflection. So the second law states that the angle of incidence is equal to the angle of reflection always. And we also have a special case from this law. If I put my laser torch along the normal such that the beam of light is falling perpendicularly on the mirror, then for this case the angle of incidence and reflection is the same, which is 0 degree. And so the ray of light retraces its path back and we don't observe any reflection in this case. Okay, to summarize this experiment, we can define reflection as the phenomena of bouncing back of light to stay in the same medium on striking any object. Now, let's start with our second experiment, which is about refraction. So for this, I've taken a glass and a pencil. Uh, I'll be pouring some water into this glass. Yes. Please. Do you observe anything strange over here? Does the pencil seem to be broken? Do you observe this pencil broken?
Yes.
Okay. So, is it really the broken pencil? Or is it some phenomena? Okay. The reason behind this is what we have been calling so far refraction. Okay. So, let's understand it. I've drawn a diagram for it. This one. Now, if you remember, while defining reflection, I used a phrase which was to stay in the same medium. So, for the reflection experiment, the incident ray and the reflected ray were in the same medium, which was air. But when we talk about refraction, the light ray bends when it travels from one medium to another. So, in this diagram, this is my pencil and this is my glass. Okay, and we have water and air over here. So, before knowing the reason behind refraction, let's understand how the bending takes place. So, this is the observer's eye, which in this case is me. So, the light from the upper portion of the pencil goes straight into the observer's eye. But for the lower portion of the pencil, the incident ray is first traveling through the water. And at the interface between the air and the water, it tends to bend in this direction and then reaches our eye. So this creates an illusion for the observer's eye, and the eye imagines the rays to be coming from a straight line. So if we extend these rays backwards, they meet over here, And so the image is formed over here. And we see this broken pencil, this image. And this creates the illusion. But it's not actually the broken pencil. Okay, now let's understand the reason. See, air is optically rarer medium because air travels faster than because light travels faster than air, and water is a optically denser medium because light travels slower in water. So, when light travels in water and it comes to the interface, it goes into air from water to air. So over here, the speed of light increases in air, and that's why it bends away from the normal. You see, this is bending away from the normal, right? Okay. Now, as I told a special case in reflection, we also have a special case in refraction. See, if I place my pencil perpendicularly, you won't see it to be broken. Do you know, na? This is because the incident ray over here is perpendicular to the normal. Actually, perpendicular to the interface and it's along the normal. So over here, no refraction takes place because the angle of incidence and angle of refraction are both 0 degree. Okay, I hope it's clear. So this was about refraction. And since we are done about our topics, let's discuss a more basic concept which occurs in our daily lives and it's taking it's taking place even right now while we are observing each other. So so I told you that a plane mirror reflects of light, but is it always a plane mirror? No, every object reflects light. For example, I take this pencil. Yeah. See, light is falling on this pencil. This pencil also reflects the light which reaches my eyes. So reflection takes place. Now, if we go into the inner working of the eye, the light rays while entering refract at the outer membrane of my eye, which is the cornea. The second time the refraction takes place at the eye lens. And then finally the object is formed at the retina and I am able to see this pencil as it is. So this is a very basic concept. Now, to conclude, we have discussed both the topics and we saw that both reflection and refraction are very much significant because reflection enables us to see everything around us, this beautiful world, and refraction is the reason behind some of the wonderful phenomena which we as a child used to imagine it as a mystery. So, to unlock more natural mysteries and create and solve illusions, we need to have a clear understanding of these concepts, which are indeed the basics of optics. So, I hope I have been successful in explaining it to you. Thank you.